I'm Mike James, and I'm going to show you how to use the calculator in a typical probability question that you could face on paper 2. Now, in this question, Evan likes to play 2 games of chance, A and B. For game A, the probability that he wins is 0.9, and he plays game A 7 times. Find the probability that he wins exactly 4 games. Now, you should realize that in this question, you're going to have to make use of the binomial distribution. Why? Because you have 2 outcomes, either success or failure, and also you have a number of trials which are independent of each other. So we're going to make use of the binomial distribution, where n is 7, that's the number of trials, and the probability of success is 0.9. So the probability of failure Q will be 1 minus 0.9, 0.1. And we need to find the probability that he wins exactly 4 games. So R in this equation here will be 4. So we substitute in the values and we basically get this result here. Now we can work the right hand side out by using the calculator. There's 2 ways of doing it. I'm going to do it both ways. So I'm going to go into the calculator mode, and the first one I'm going to do is to multiply the whole thing out. I'm going to multiply the 7c4 by the 0.1 cubed times 0.9 to the power of 4. Now 7c4 you can get by clicking menu, and you can go to probability and go to combinations, and you get NCR. So all you need to enter now is 7, 4, and press enter. So 7c4 is actually 35, so I'm going to copy that now by hitting the up arrow, press enter, and then multiply that by 0.1 all to the power of 3. So I'm going to raise that to the power of 3, hit the right arrow, and then multiply that by 0.9 all to the power of 4. And press enter. There's the result, 0.022964, and you can give that to 3 significant figures, which is 0.0230. Now I'm going to do this calculation a second way by hitting menu, going down to probability, and going to distributions and binomial CDF, not PDF but CDF, and I'm going to put in the number of trials, which is 7. And I'm going to tab to the number of next box, which is the probability of success, which is 0.9, and I'm going to tab to the lower bound. Now we take that as 4 because we want to find the probability that he wins 4 particular games, so we put 4 in there, and then we hit the upper bound, which is also 4 as well. So we tab to OK and click enter. So we've got virtually the same result, and if you round this to 3 significant figures, you get 0.0230 again. So that's the end of the first part. Now for game B, the probability that Evan wins is P. He plays game B 7 times. Write down an expression in terms of P for the probability that he wins exactly 4 games. Now this time it's an identical question to the first part, except that we don't know what P is, and we need to write down probability of x equals 4 equals 7c4 again, but we don't know what P is, so I'm going to replace Q by 1 minus P to the power of 3 and P to the power of 4. So it's identical to this result here, except we are not given P. Now I can simplify the 7c4. If you remember, that's 35, so I've tidied it up a bit. That's about as simple as it can get. Okay, so we leave the result like that, and we go on to part C. Now part C says, hence find the value of P such that the probability that he wins 4 games is 0.15. So basically we need to make use of this result in part B to answer part C. So we replace probability of x equals 4 by 0.15, and we get this equation here. Now our aim is to find P. Now you can't solve it manually, it's too complicated, so they expect you to use the calculator. Now you could try using nsolve, but unfortunately there is more than one result, so it's best to sketch actually find the values of p by sketching. So what I'm going to do is sketch the graph y equals 0.15, and I'm also going to sketch the graph y equals 35 times 1 minus p all cubed, p to the power of 4. And where the two graphs intersect will give me the values of p that satisfy this equation here. So let's do that on the calculator. So I'm going to go into graph mode, and I'm going to enter in f1x is equal to 0.15 and press enter. Now that's not very promising, because you can see that it's just a straight line, horizontal line, but it's very close to the x-axis, so I'm going to have to adjust the scale probably. So I'm now going to hit tab again and put the second graph in anyway. So I got 35 times 1 minus, now I can't use p, I have to use x. Okay, bracket, and I've got to raise that to the power of 3. Hit the right arrow, that's important there, and multiply that by p to the power of 4. Again, I can't use p, I have to use x because it's f2x here, so I'm going to put in x to the power of 4. Okay, so there it is, and I'm going to hit enter. Well, I can see the graph, but it's a bit difficult to see where the graphs intersect. So I'm going to adjust the scale a bit on this. Also, I might just move this around a bit because it's going to get in the way. So we need to find the values of x where these two graphs meet, and so you need to adjust the scale because it's not very clear. So I'm going to go to menu, I'm going to hit window zoom and go to Windows settings and adjust some of these values. Now sometimes you have to do a bit of trial and error here, but I'm not really interested in the negative x values, so I'm going to make that -1, and for the x maximum value I'm going to take this as +1 because everything's very cramped about the y-axis. And for the y minimum, this is quite important, I'm going to take a pretty small value, because so -0.05. Now I have tested a few of these, so we should get a decent graph, and y maximum I'm going to take as 0.5, so this will enable us to see that horizontal line. So I'm going to click OK, and that's a lot better now. So you can see there's the x-axis, and there's the graph y equals 0.15, this straight line here, and you can see the other graph quite clearly now. So we need to find these points of intersection. Now one way of doing it is to hit menu and go to Analyze Graph and go to Intersection. Now you'll see lower bound come up, and you see this dotted line, a vertical line which I'm moving back and forth, and you can just see it on your calculator, that dotted vertical line. So what I'm going to do, I'm not interested in this negative value of x. Obviously there's 3 points of intersection here, because remember we want values of p that are positive. You can't have p negative, because remember p is a probability and you can't have a negative probability. So we're not interested in this first point of intersection of the curve and the line. So we're interested in this first one here that's positive. So I'm going to, for the lower bound, I'm just going to hit enter. Okay. Now you'll notice that it changes to upper bound when I go to the right of that point of intersection, and I need to hit enter again there, and there it is. You can see 0.355848. So that's my x value for the first point of intersection. Now I need to find the other point of intersection, because there looks like looks like we got two answers that are going to be between 0 and 1. Now remember, P has to be between 0 and 1 because it's a probability. I'm going to move this one out of the way because it's going to probably overlap with the next answer. So I'm going to repeat the procedure. I'm going to hit Menu, Analyze Graph, and go for intersection again. And again, you can see my vertical line, only this time I'm going to, it's got lower bound, you can see in the bottom left corner. I'm going to hit enter there, and now I'm going to drag to the right of that point of intersection, hit enter again, and I've got a point here, and I'm just going to move it across, and there it is, 0.769743. So those are my two answers. P must be between 0 and 1, so we have two answers between 0 and 1. Remember, a probability can't be less than 0 or bigger than 1. So we can copy that from the graph, and here they are. So the P is 0.3558, which is 0.356 to 3 significant figures, and P is 0.7697 or 0.770 again to 3 significant figures. So that's how we work out the probability question using the calculator.